Eventually of delivery, front office.
Okay, so you can I can hear in this room, so I have audio, so you can talk to me that way, or I will open up the chat box and have that where I can see that if you want to send something in that way. So sorry for being late. It's been kind of a crazy day. So this is going over the review for Math 1350. This review is posted on week 14. The solutions are also posted on week 14. And we have like an hour to go over whatever you want to go over. So what would you like to go over on the review?
I guess I'll start off. Can you, this sounds silly, but can you do number 1?
No, it's not silly. Yes, let's do number 1.
I guess the part do not convert to
Yes.
decimals and not thing.
Okay, so we're trying to figure out, we have the fractions 3/4 and 7/8, and we're trying to figure out where 5/6 is at in the middle of it. So like, is it closer to the 3/4 or is it closer to the 7/8? And it's hard to just look at, like, I can't just look at those fractions and tell which one it's closer to. So since we can't convert to decimals, a way we can do it is by getting a common denominator. So we're getting a common denominator for 4, 6, and 8. So 24 would be the least common denominator for all 4 of those. So let's turn them all into a fraction over 24. So to turn the 4 into a fraction over 24, we need to multiply the bottom and top by 6. And we get 18 over 24. For 6, we need to multiply it by 4. And so we get 20 over 24. And then for the 8, we need to multiply by 3. And so we get 21 over 24. And now that they all have the same number of pieces, you can see that 20 pieces is closer to 21 pieces than it is to 18. So it would be closer to 7/8. What else?
That one was like similar to like the one that we did. There was which number is in between these 2 fractions?
Yes, yes.
Thank you.
You're welcome. What else? Do you want to go over the addition or subtraction, like 3, 4, and 5?
So I just have a general question. I'm not really good at drawing cubes. Is there another way to indicate, I guess, that this is the cube versus the flat? So it makes it easier, especially for time-wise on the test?
I mean, the only other thing I could think of is drawing a square and like writing cube in it or putting a C in it or something like that. That would work too.
Okay, yeah, because then I get all caught up on it being like a perfect cube and I'm like, I don't got time for that.
Yeah, that's fine. Or multiplication, doing the area model.
Go over number 5.
Yes, number 5. So adding 2 fractions using the line model. So it's 1/2 plus 4/5. So for that one, we're gonna draw a number line, and 1/2 plus 4/5, it's gonna be more than a whole, but it's gonna be like less than 2 wholes. So I really only need to go to the number 2 on my number line. So you could start off by splitting your number line into halves. So that would be 1/2, and that would be 1 and 1/2. And then from here, you need to split each section into the other denominator pieces. So I need to split this section into 5 pieces, this section into 5 pieces, so on and so forth. So I'm going to split it into 5 pieces, 1, 2, 3, 4, 5. And we'll name the pieces in just a second. So to figure out the name of each piece, you need to see how many pieces are in a whole. So from 0 to 1, there is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces in a whole. So the first one would be called 1/10, 2/10, 3/10, 4/10, 5/10, which is already named 1/2, and they have the same name. 6/10, 7/10, 8/10, 9/10, and 1 whole. Same thing past that, 1 and 1/10, 1 and 2/10, 1 and 3/10, 1 and 4/10, 1 and 5/10 has the same name as 1 and 1/2, 1 and 6/10, 1 and 7/10, 1 and 8/10, 1 and 9/10, and then 2 wholes. So we're going to start with 1/2, and that's already labeled on our paper. So start with 1/2 is this long. And then I want to add to it 4/5. Well, to add 4/5 to it, our number line isn't in fifths, it's in tenths. So you need to think about what is 4/5 in tenths. So to turn 5 into 10 on bottom, we need to multiply by 2. So that would be 8/10 is what we're going to add to the 1/2. So we're going to count over 8 sections from where we're started at the 1/2. So 1, 2, 3, 4, 5, 6, 7, 8. So it's going to come all the way to right here. And that is 1 and 3/10. And you could have turned that problem around. You could have done 4/5 first and then added 1/2 to it if you wanted to. It's going to be the same answer. Just a heads up, students have the hardest time seeing that that's the same problem. 4/5 plus 1/2 and 1/2 plus 4/5. So I'm fine with you doing it on your test like that, but like when you're teaching, I have a 2nd grader that I'm homeschooling at home, and it's so funny how we're doing a problem and I'm like, just add 6 and 4. And he's like, but it's 4 plus 6. So I'm like, well, okay, same thing, but whatever. So they just have a really hard time with the commutative property. What else? Number 23, let's look at that one. Okay, so this is division of decimals. So this is how and why. So if I want to do 6 and 45/100ths divided by 1 and 75 thousandths. The how part is like, what's the algorithm to actually do it? So I put the 1 and 75 thousandths on the outside. I put my division bar, and I do 6 and 45/100ths on the inside. And then I need to move my decimal place so that I'm not dividing by a decimal. So I need to move my decimal place over 1, 2, 3 times to the right. I have to do the same thing on the inside, 1, 2, 3 times to the right. So I essentially changed this problem into 6,450 divided by 1,075. And my decimal place is going to stay there. I'm going to have that decimal place in my answer now. And then I'm gonna divide it. So how many times does 1,075 go into 6? Can't do it. How many times does it go into 64? Can't do it. How many times does it go into 645? Can't do it. How many times does it go into 6,450? Let's see. We'll go 5 times. Yeah, we'll go 6 times. Oh, 6 times, perfectly. So it goes 6 times. And 1,075 times 6 is 6,450. And so when I subtract it, I get 0 left over. So the answer is 6. And the process for doing that is write it as a normal division problem, move your decimal over so that you're not dividing by a decimal, you're dividing by a whole number. And it changes the problem to this. Okay, so why, the question of why can I turn 6.45 into 6,450 and turn 1.075 into 1,075? Well, the reason why is because the 6.45 is 6 45/100ths, which I could make that into an improper fraction. 6 times 100 is 600 plus 45 would be 645 over 100. And then same thing with the other one, 1 75 thousandths is 1 75 over 1,000. Again, I can make it into an improper fraction, which would be 1,075 over 1,000. And so all I did so far was take my decimals and turn them into fractions. So now let's divide 645 over 100 divided by 1,075 over 1,000. It's easiest to do this if we have a common denominator, so we can get a common denominator here. 1,000 and 100, the common denominator would be 1,000. So I need to multiply by 10 on bottom and top, and it turns it into 6,450 over 1,000 divided by 1,075 over 1,000. And when I divide across the top, I get 6,450 divided by 1,075 over 1,000 divided by 1,000 is 1. So that's the why of why can I change this decimal into this whole number problem, is because if I break it up into a fraction and think about like the number of pieces I have over the number of pieces I take to make a whole, the pieces to make a whole end up like canceling out or dividing out at the end, and I'm just left with my big numbers there. Okay. So this problem isn't necessarily like 6, like that's not really the answer we're going for. It's what's the algorithm, like what's the rule to do it, and then why does that rule work? What else?
Can you go over number 8, please?
Hmm? Number 8 is rectangular area model. Okay, so this is 2 3/4 times 1 1/3. So rectangular area model is where you're drawing 2 3/4 on a number line one way and 1 1/3 on a number line the other way. And you can't stop at 2 3/4, you have to go all the way up to 3. Same thing here, you can't stop at 1 1/3, you have to go all the way up to 2. So, so 2 3/4. So this is 0, 1/4, 1/2. Oh, sorry, say 2/4, 3/4, 1 whole, 1 1/4, 1 2/4, 1 3/4, 2 wholes, 2 1/4, 2 1/2. Oh, sorry, 2 2/4, 2 3/4. That's as far as we're gonna shade to, but I do need to go ahead and go all the way up to 3 holes. And then the other direction, I'm gonna do 1 1/3. So I'm gonna say that's 1/3, that's 2/3, that's 3/3, which is a hole. This is 1 1/3. That's the point that I'm going to shade to. And then I have 1 2/3. I have to go all the way up to the next hole, and that's 2 holes. So this is my, the area model, like my array. With all my pieces in it. Okay. Also, I'm recording this and I'll post it on D2L if you want to go back and watch it back if you miss anything on this. So then we're shading. We can shade all the way over to 2 3/4 and all the way down to 1 1/3. So it's going to be this section right here. So my answer is how many pieces do I have over how many pieces it takes to make a hole. So I need to count up the pieces that are shaded in. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It was like 44 pieces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 44 pieces that are green. That's what I have. And the number of pieces it takes to make a hole. It's not this whole rectangle we have here. It is the pieces it takes to get to 1 hole on this side and 1 hole on this side. This is the hole right here. Okay, so that many pieces is my hole. So I'm gonna write that hole. So that many pieces is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 pieces to make a hole. So my answer is 44 out of 12. If you want to reduce that, you can. It would be 11 over 3 if you reduce it. If you want to make it a whole a mixed number, that's fine too. I would just leave it as the improper fraction like that though. As a mixed number, it would be 3 2/3. And like you can technically see those pictures, see the picture of 3 2/3 because I could, like, if that's 1 hole, I could make 1, 2, 3, 4, another hole here. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This would be 1 more hole right here. And then there are 1, 2, 3, 4, 5, 6, 7, 8 pieces out of 12 left over, which is the same thing as 2/3. You don't have to do all that. Just leave it as that though. Okay, somebody else asked about number 15. So let's look at number 15. 15, you're given the problem 2 times 10 to the negative 2. This is written in expanded form with exponents, but it's not super nice and neat like in order. Plus 4 times 10 to the 3rd, plus 5 times 10 to the negative 5th, plus 3 times 10 to the negative 4th, plus 6 times 10 to the negative 6. And you're asked to write that as decimal. Let me check and make sure that they're right. -2, 3, -5, -4, -6. Okay, so for this one, I think the easiest way to do this is to put these little place value marks, like make the like blanks for your place value. So like the biggest number, the furthest number, place value position on the left would be 10 to the 3rd. Okay, so that's going to be your biggest number because that's the highest exponent we have here. So this is going to be the place for 10 to the 3rd. Next is 10 squared. After that is 10 to the 1st. Then we have 10 to the 0 power. That's the ones place. After that, we have our decimal. And we move on to 10 to the negative 1st power. 10 to the negative 2nd power. 10 to the negative 3rd power. Our lowest exponent, our smallest exponent, the biggest negative number we have is 10 to the negative 6. So we have to go all the way to negative 6. So 10 to the negative 4th, 10 to the negative 5, 10 to the negative 6. So that's the size of our number that we're going to be putting here. And numbers that go in each of the place value position, or the digits that go in each of the place value position, is the number in front. So I have 2 of these 10 to the negative 2 power. So I'm going to put a 2 in the 10 to the negative 2 power. I have 4 of the 10 to the third, so I'm going to put a 4 there. I have 5 of the 10 to the negative fifths. I have 3 of the 10 to the negative fourths, and I have 6 of the 10 to the negative sixth, and then I don't have any of the other numbers, so those need to all be zeros. So your answer is 40,000, and then this 20356, and again, the way you say that is 020356. And the way you would read this is it's 20,356, and then you tell that last place value, which is tens, hundreds, thousands, 10,000s, 100,000s, millions. So if you're going to write this in words, it would be 40,000 and 20,356 millionths. Okay. Oh, I messed up. That you should have told me. Y'all are looking at me funny. I put this 0 over here on this side. This is 4,000. Okay, so let's take off the 0. There you go. How about that? Move the comma over. Sorry about that. I put the decimal place in the wrong spot. So it's 4,000. Let me just start over. 4,000, 020356. So in words, it's 4,000 and 20,356 millionths. What else?
For number 24, where it says to change the decimal to a fraction, if it's able to be reduced, do you want us to do that, or can we just leave it as is?
Either way, it's fine. I'll take either way. I think I specifically picked a number that didn't reduce on your test so that it wouldn't be a problem. But either way is fine. What else? Number 14. Okay, let's look at 14. It says that Bill, Dan, and Ed went to the grocery store to do some shopping. They figured based on how much time each of them eats at their apartment, Bill should pay 3/8 of the bill. So he needs to pay 3/8 of it. Dan needs to pay 1/3 of it. And Ed should pay the rest. If Ed paid $35, so he paid $35, how much was the total grocery bill? So you could do this a couple of different ways. I'm gonna start off by drawing a picture. So we're gonna say this is their grocery bill. We're gonna do like an area model. I need to be able to take away 8ths and 1/3. So I need to pick a denominator that can split into 8 parts and 3 parts. So I'm going to pick the denominator of 24. So I'm going to do it. You know what, let me do 8ths this way and 1/3s this way. Okay. Sorry, I'm thinking through how to draw 8ths. There we go. So 1, 2, 3, 4, 5, 6, 7, 8. And then 1/3s, you know, it doesn't matter. You could have done it like 6 one way and 4 the other way. It doesn't really matter. So Bill paid for 3/8 of it. So I'm going to take away 3 of my vertical sections. So I'm gonna take away, or I'm gonna shade it in. We're gonna say this is Bill. So the green part is Bill's part of the bill. Okay, Dan did 1/3. So here's kind of the mistake here. 1/3 is one section this way, right? Which is 1, 2, 3, 4, 5, 6, 7, 8 pieces. I can't just shade this bottom section right here because I've already used up 3 of those pieces for Bill. So you just need to make sure you shade in 8 pieces, however you want to. So I'm gonna shade them in like this, 1, 2, 3, 4, 5, 6, 7, 8. And this is Dan's part. So you can use your horizontal line to figure out how many pieces it is, but don't like shade that in because we've already used part of it, part of your horizontal line for Bill. And that's like double using part of it. Okay, so the rest of it is Dan's, nope, Ed's. So Ed has 1, 2, 3, 4, 5, 6, 7 pieces left. Okay, so this all is how much Ed paid for the bill. So there are 7 parts left over. And he paid a total of $35. So 35 divided by 7, that means each of these parts of the bill is worth $5. So this is worth $5, this is worth $5, so on and so forth. Or another way you can think about that is if he has 7 boxes here, it's supposed to be a dollar sign. I don't know why I switched over to number signs. If Ed has 7 boxes here to fill in and his part's $35, like how do you split $35 into 7 boxes, $5 a piece. So from there, we know that all of these boxes are $5 because these are all equal sized pieces. So the bill is like how much they paid for the groceries is $5 times the number of pieces we have here. There are 24 total parts and each part is worth $5. So that's going to be 24 times 4 is $120. I said 24 times 4, 24 times 5 is $120. You can do that problem other ways. I feel like, for me at least, this is the most straightforward way to do it. You could start off with one whole bill, like one whole grocery bill, subtract Bill's part, subtract Dan's part. When you do that, you'll end up with a fraction. The fraction is going to be 7/24. And then you have to figure out, like, if this is Ed's part and he paid $35, how do I figure out what the whole is? So I feel like the picture is a little bit easier here versus like actually just working it out using an equation. What else?
Number 25, please.
25, okay. So for number 25, we're asked to show 0.1, 0.10, and 0.100. Okay, so this would be read as 1/10. This would be read as 10 hundredths. And this would be read as 100 thousandths. Okay, so we know they're all equal because you can just drop the zeros and they all are the same decimal, but they all have different pictures using base 10 blocks. It says that the cube is the unit. So if the cube is the whole, that means that the flat would represent 1/10, and the long would represent 100, and the unit would represent 1,000. So based on that, 1/10 would be one of my flats. 10 hundredths, hundredths are the longs. So I need to show 10 longs. 7, 8, 9, 10. And then 100 thousandths, I need to show 100 of the units. You don't have to sit here and draw 100 of the units. So 100 of these. And it says show the equality of this. So these are 3 different pictures. You could draw out 100 dots if you wanted to. But they're equal. We know the decimals are already equal, but the pictures are also equal because one flat is the same as 10 longs, which is the same as 100 units. So one flat equals 10 longs, and that equals 100 units. So that's showing that 0.1 is equal to 0.10 is equal to 0.100. What else?
Number 10.
Number 10. Okay, so for this problem, we are taking division of fractions 2/3 divided by 4/5. And we're saying, why are we allowed to just turn that problem into 2/3 times 5/4? So the idea here is if I take my 2/3 and let's divide it vertically, like put it on top of a fraction. Let's put 4/5 on bottom. So something divided by something else. That's kind of a mess. It's called complex fraction, which is, people don't like fractions in the first place, but then fractions inside of fractions makes it even worse, right? So a way to fix that is, let's make this number on bottom a nicer number, okay? So if I multiplied the top number by something and the bottom number by something so that I got the same number over the same number, that would just become one whole, and then that whole part of the problem goes away, right? So there's a lot of different numbers you can pick. The easiest number to pick is if I multiply the top number by 5 and the bottom number by 4, they both turn into, I don't know where that came from. They both turn into a 20 on top and a 20 on bottom. And 20 divided by 20 is just 1. And that whole part of the problem's gone. Well, the issue here is I'm not allowed to just randomly multiply by 5 on top and a 4 on bottom. Like, that changes the complete problem. So what I have to do is I have to do the same thing up here, because now if I have 5/4 on top divided by 5/4 on bottom, anything divided by itself equals 1. So I'm not actually like changing the problem. I'm just multiplying by 1 in a fancy way to make it work out the way I want it to work out. So then you notice that 2/3 times 5/4 is on top. And that is what we were trying to get to, was 2/3 times 5/4. So the reason why you're allowed to change its multiplication and just flip is because it's like just multiplying by 1. What else?
Number 20.
20. Okay, so a decimal between 1 and 599 thousandths and 1 and 6/10. There's a couple different ways you can do it. I would probably say the easiest way to do this is make this decimal be as big or as long as the other decimal. So I could put 2 zeros here. So then this is now 1 and 599 thousandths and 1 and 600 thousandths. Still, there's not a number in between 599 thousandths and 600 thousandths. So if I add another 0 to both of them this time, all I'm doing is adding zeros, so I'm not changing the decimal. But this is now 5,990 thousandths. This is now 6,010 thousandths. So is there a number between 5,990 and 6,000? Yeah, there's a few of them. Pick one of them. So I'm going to do 1 and 5,992 10,000ths. Or it could be 3, or it could be 4, or 5, or whatever you want. What else? Okay, so I will go ahead and post this video on D2L on week 14. I'll also post the video from last semester of the Zoom call for exam number 3, like I have been, because it's probably going over other problems that y'all didn't cover today. So I'll post both of those videos and I'll just name them like fall 2020 and spring 2021 so that you can watch both of them. Okay. So your exam is the same or similar to like exam number 2. There's a D2L part, and then there's like that last question that you work out, and then you upload your work on the assignment, like the exam number 3 work assignment. And I'm headed back to my office now to go send out emails with all the instructions, you know, all that sort of stuff. So if you have any questions, let me know. You can send me an email or however you need to, and I will let you know.
Thank you.